So for today, we can get started. So we have really ambitious plans for today workshop. It is systems of equations and all the procedures connected with this type of math questions. So our plan is all these exercises from intermediate algebra textbook. They are all there, so you can go after our workshop and try again if you have any concerns about these questions. Let's go. 2 by 2 systems of equation. We need to solve it by graphing. So I will give you some time, and then we will share our answers, and I show you the solution.
Okay, everything seems good?
Seems so.
Okay, I'll head downstairs.
So while you are solving, anyone can tell me what is the first step to do this task?
We should find the points.
How are you going to find the points?
Maybe make the x equals 0 and y equals 0, and we can find the 2 points on the x and y axis.
Yes, as one variant, it works. You're right. Okay, so let's try to use interceptions. Firstly, we can choose if x equals 0. So we'll have minus 3y equals 8 and minus 6y equals 14. So y equals minus 8/3 over 3, and y equals minus 14 over 6, which is minus 7 over 3. So it is the first, it is the second. So x equals 0, and first is, let's make it clearer, 2 and 3 minus. Okay, 0, 2, approximately over here. And the second one, also need to find the whole number. Here is 2 and minus 2, 1/3. Y equals somewhere here. Oh, I forgot about the minus. We need to go down. So minus 2 and 2/3 is over here. And 2 and 1/3 is over here. For y part, for x equals 8. Oh, how it works. For x equals 8 and 8x equals 14. So here x equals 2 and here x equals 14 over 8, which is 7 over 4, which is 1 and 3/4. Okay. So y equals 0 and x equals 2 here. And x equals 1 and 3/4, somewhere here. I think we did something wrong. Yeah, we definitely did something wrong. Okay. We did correctly, but in fact, these equations are parallel to each other. So they don't have an intersection point. So this system of equations don't have solution, do not have solution. In fact, if we solve it a bit another way, so making the slope-intercept form, it would look like y equals 4 over x minus 8 over 3. And the second will look like 4 over x minus 7 over 3. So we can see from these equations that the x part, the coefficient in front of x, is the same. So the slope is the same. The only difference is in these parts, which simply regulates the difference of the line, like how down or up it goes. So if we made this slope form, we could directly see that these lines are parallel to each other and that we don't have the intersection. Anyone have any questions? Can you show me closer? A student in class have a question, so what? Что из этого вот это и вот это? Не, просто не понимаю. Вот это, вот это. Okay. So the question was the exact answer for this question. All this, what we found, these parts, are the dots that we need to draw these lines. So if you look at this, so it is 1, 2, and 2. And here are the dots. Here the first one, and here the second one. So this system do not have the solution because the lines do not intersect. They are parallel to each other, what we can see from this slope intercept form. What we found is the points that we use to draw a line. Okay, let's continue. By the way, when you write the answer to such problems, please clarify it and write like lines parallel, no solution, or no intersection. So be precise in your answers. You need to state this for us to evaluate your answer. Oh, 1 second. I got it. So here, we need to solve two systems of equations with two different approaches. The first one is substitution, and the second one is elimination. For the first one, you need to isolate either y or x and input it into the second equation. For the second task, you need to add or use algebraic operations to eliminate one of the variables, like add or subtract equations from each other to get rid of x or y. If you're ready, you can type your answers in the chat. Okay, seems that mostly we get the idea. So let's look at the first one. Here we have the most convenient situation when we have isolated y for both parts. So let's just substitute. So x minus 6 equals minus 3 over 2x plus 4. So we just use this and put it here. So 3 over 2x plus x equals 6 plus 4. So 1, 3, 2x equals 10. So 5 over 2x equals 10. X equals 2 divided by 5. Yes. And 1, 2, 4. And then we can input this value of x into the first equation, which is x minus 6. So for us, y equals 4 minus 6, so minus 2. The answer is 4 minus 2. Please, when you write the answer, make sure that you write x first and y second. It is very, very important. Pay attention to this. For the second task, we can see that we have fractions here and here. We don't like fractions, so we can get rid of them. To get rid of, we firstly multiply the first equation by 2 to have the same coefficient in front of x. And then we divide, or we subtract the second equation from the first one. What do we get? Here we have 0. Here we have minus y minus 5 over 2y equals minus 3 minus 3. So we have minus 6. Here we have 2 and 1 over 2 y. Let's check for me to make sure. 1 y minus 2 and 1 3. Okay. So we have y equals -6 divided by 3 minus 3, 1/2. So to make our life easier, it will be okay. It seems to me that I'm doing something wrong. Yes. Here I forgot that we multiplied by 2, so we have -6 minus 3. So we have not 6 but 9. So we have -2/5y. To get the value of y, we need to divide -9 over this fraction. So we need to make it easier, like without this full number. I don't remember the English word for this, I'm sorry. So divide by 9/2 with minus. Minuses are gone. So 9 multiplied by 2 divided by 9. Here we have 1, 1, and y equals 2. Okay, no more confusion. And then when we get the value of y, we need to put it into one of these equations to get the value of x. Let's use first one. 1/3x minus 2 equals -3. So 1/3x equals -3 plus 2. 1/3x equals -1. So x equals -3. There was a question in class, why do we need to multiply by 2 in this case? Take a look that we have different coefficients in front of x. We have 1/3 and 2/3. We need to use elimination for this question. So we need these coefficients to be equal to get rid of x. If we have like 1 minus 1, we get 0. The same is here. If we multiply by 2, we get 2/3. So these fractions will be equal. And when we subtract 2/3 x from 2/3 x, we have 0x. So we have only y's in the new equation. We can do the same for y, but y here has coefficient 1, and for both x we have like fractions. But you can do this for y or for x as you like to. There is no big difference, just make sure that you make the correct calculations and don't forget to multiply by 2 everywhere, as I forgot for this part. Okay, I hope we are done with this and we can continue. So for now, we will use systems, 2x2 systems of equations to solve the problems. So here we have a baseball game and several types of tickets. So here we have good seats, which costs $69, and cheap seats, which cost $39. 16 people went to see the game, and for 16 people, they spent like $804 for the tickets for all of the 16 people. We need to find how many good seats and how many cheap seats were bought. So for clarification, let's have X for good seats and Y for cheap seats. When you are done, type your answers in the chat, please. Okay, so let's take a look. So X is the number of good seats, while Y is the number of cheap seats. And overall, we had 16 seats. So our first equation will be number of good seats plus number of cheap seats and the overall number. And we need to do something with the cost. So if we multiply the cost of good seats by the number of good seats, then we need to add the cost of cheap seats multiplied by number of these seats, and we should get 804, the amount of money that the group of people spent on these seats. Any questions for this part before we start solving? Everyone understand how we get these two equations? Okay, so let's use substitution for this part. So we have y equals 16 minus x. Actually, substitution here is a bit difficult because we have huge numbers. But even though if we want to multiply, we would have to multiply 16 by 69 or 39, so inconvenient either. So we'll have 69x plus 39 multiplied by 16 minus x equals 804. So let's go for the 69x plus, we need to multiply 39 by 16. We cannot use calculator, so let's do this. 6 by 9, 54. 3 by 6, 18, plus 5, 23. Am I doing right? No, I don't. Ah, by the way, before doing this, we can take a look whether we can make the equation simpler in order not to multiply by so many numbers. Like we have 69 and 39. It definitely can be divided by 3. So let's try to divide it by 3 and check what we have. So 69 by 3 is 2 and 3. Works. 39 by 3 is 1, 3. Works. Okay. And 804 by 3, we can try. So I was told that I have weird methods, but still. So 3, here we have 6, here we have 2. 20, here we have 6 minus 18, and here we have 24, 8 minus 24, 0. So we made our equation simpler. And now we can open the brackets eventually. 23x plus, and now we need to multiply. Here we need to do so. So 6 by 3 is 18. 6 by 1 is 6, and plus 7, 8, 78. Here 3, here 1. So 8, 0, 2, 208. Minus 13x equals 206, 8. So we have 10x equals 60. So we have x equals 6. So here we can see that 6 good seeds were bought. And now we have x plus y equals 16. And we put the value of x in this equation. So equals 16. From what I can get that y equals 10. Any questions about the solution, about the task, how we use systems of equations here? Are you okay? Great. Hope in Zoom everyone are also okay, and we can continue. So now we're moving to the more difficult part, 3x3 systems of equations. So here we have 3 variables and 3 equations. This can be confusing and you can easily get lost because we have a lot of variables actually compared to the previous one. But the procedures are quite the same, just need to be more attentive, not to lose anything. So we can try to solve it and then we will solve it together. Okay, let's try to solve it. So for us to be precise, we'll have the first equation, the second, and the third one. So the first step, Jan, you mixed the signs of y and z, but yes. Okay. So for the first part, we will multiply the first equation by 2 and then subtract the second equation from the first one. So we have 6x plus 2y minus 2z equals 4 minus 2x minus 3y minus 2z. equals 1. What do we get? 6 minus 2, 4. 2 minus 3, 2 plus 3, 5. Minus 2 minus 2 minus 2 plus 2, 0. We don't have. And everything equals 4 minus 1, 3. So this will be our equation number 4. For the second step, what we are going to do? We are going to subtract the third equation from the first equation. And the first equation will be multiplied. Let's get clear in order. We'll have first equation multiplied by 3. And then we subtract third equation from first equation. All we do is we are trying to get rid of z. We don't need one more variable. We need our default x and y ones to solve. So we need to get rid of it. The first, like we do some procedures with the first and the second, and the first and the third. It's a common approach. So let's take a look. We will have 9x plus 3y minus 3z equals 6. Then we need to subtract, and we have 4x minus y minus 3z equals 0. What we have here? 9 minus 4, 5. Not clear, 5. 5. 3 plus 1, 4. And again, we don't have z. And 6 minus 0, 6. It will be our fifth equation. Then here, what we do, we use the equations we get that contains only 2 variables and combine them into one system. So we have 4x plus y equals 3 and 5x plus 4y equals 6. Familiar? Yes, we did this just recently. So now we need to use either substitution or elimination to get the value of x or y. Let's do elimination. We'll be eliminating yx, it doesn't, let's y. So here we need to multiply by 4, and here we need to multiply by 5, because we need to get rid of y. The common value for 5 and 4 is 20. So here multiply by 4, here by 5. So what we get? 16x plus 20y equals 12. Then we have 25x plus 20y equals 30. And then just subtract. 16 minus 25 is 9. Here we don't have anything. And 12 minus 30 is minus 18. So minus and minus are gone. So we have x equals 2. So now we can use any of the equations. Let's use the first one, equals 3, and input our x value here. So we have 4 multiplied by 2 plus 5y equals 3. So we have 5y, 3 minus 8. 5y equals minus 5. So y equals minus 1. Minus 1. And the last step, we use both these values and input them into, let's say, the first equation, x, 3x plus y minus that equals 2. So x is 2, so 6 minus 1 minus that equals 2. So minus that equals 2 minus 6 plus 1. So minus z equals 2 minus 6. 4 plus minus 4 plus 1 is minus 3. So z equals 3. Just here we need to be accurate and precise, not to lose any number and not to mix something up. Everyone is clear. If you are not finished with writing, you can take a screenshot. So let's continue. So here is the illustration how 3 by 3 systems of equations work actually. So we have only one solution when the all of 3 dimensions have common point, and we have multiple solutions if they like lie in the same. It's difficult to explain because I don't remember the terms in English. So you can see when the dimensions intersects in a line or overlay over each other, we have multiple solutions. If they have only point in common, we have one solution. And here we don't have solutions, but because we don't have any place, point, or line where all of the areas intersects, like the visual representation for you to get the idea. So this system of equations is kind of easier than the previous one. So try to solve it and then type your answers in the chat. Okay, we got some answers in the chat. So let's take a look. We have only two variables in each equation, so we need to choose two that we will simplify the system to. So x and y. We have that here, so we can multiply the second by 2 and get rid of z. So here we will have the procedure: the second equation multiplied by 2, then we subtract the second from the first one. So what do we have? 3x minus 4z equals 0, and 6y plus 4z equals minus 6. So what do we have here? 3 plus, we have 3x plus 6y, and we don't have that anymore, but we have minus 6. It will be our fourth equation. Then we can use the third one because we have the same variables there, and take a look what we can do with them. So of our new one and the third one. So I suggest using elimination. So we need to get rid of one of the variable. If we just multiply by 2 this part, we will get 6 exactly. So let's try doing this. So what we get? 3x plus 6y equals 6. And here we have 4x plus 6y equals minus 10. And we need just to subtract. So we will have minus x, we won't have y, and we will have 4. So x equals minus 4. Then we can use our first equation. Oh, let's use third one. 2x plus 3y equals minus 5. And input x there. So we have minus 8 plus 3y equals minus 5. 3y equals 3. So y equals 1. And now we can use the same value of x to get our value from the first equation. Minus 12, because x is minus 4. Minus 4z equals 0. So minus 4z equals 12. Then that equals 3. That equals minus 3 because we need to have plus here. Okay, you can take a screenshot if you're not done yet, and we will continue. Here, the same, we need to solve system of equations 3 by 3. Okay, let's take a look. What do we have here? So I can see that I have x here, and in the third equation. How about getting rid of all these x's? So to get this, we just add the first to the second and subtract the third. So what do we have? X will be gone. 2 minus 3. Yes. 2 minus 3 and plus 1. 1 second. Okay. 2 minus 3 minus 1 plus 1. I think I got some run idea. So let's do the same as we done with the first one. So first and the second. So x plus 2y minus 3z and x minus 3y plus z equals minus 1 and 1. We have x and x here, so we can easily get rid of it. Minus. What we will get? Here nothing. 5y and 3z minus 3z, or minus z minus 4z. And 1 minus 1 minus 1 minus 2. Our fourth equation. What we will do next, we will take a look at the second or third, or first and third. What we would like to, we need to get rid of x, so let's take a look at first and third. To get rid of x, we need to multiply the first equation by 2 to get the same coefficient. So we will have 2x plus 4y minus 6z equals minus 2. And then we use minus 2x minus y minus 2z equals 2. So x are gone. 5y minus 6 plus 2, 4. And we have minus 2 minus 2 minus 2 minus 4. So what you can see from here, we have the same variables with the same coefficients, but they are equal to different numbers. So this system do not have solutions. Any questions about this part, about no solutions? Any concerns? Maybe somewhere to clarify? We need to check coefficients in front of variables to get the idea whether they are parallel or not. We just cannot say it from scratch here. And also we have like 3 lines and 3 of them cannot be parallel. Yes, they could, but we don't have the details about x for now. So let's go further. And now we will have to use 3x3 system to solve another text problem. So what do we have here? Oops. What do we have here? So here we have again tickets, but now we have 3 kinds of tickets. Adult tickets, which are sold for $15, student tickets for $10, and child tickets for $8. The theater sold 250 tickets, and all these tickets cost $2,825. And the task is the same. We need to find the number of each type of ticket. So for adults tickets, we use A as an alternative to our X, Y, Z. For student S, and for child C. So try to solve it and then we will check. If you're ready, type your answers in the chat. And also pay attention that we have one more clarification here, that the number of student tickets sold is twice the number of adult tickets. So students, there were 2 times more students than adults. So let's get to it. What we have? Firstly, let's take a look at the easiest part. Student tickets twice the number of adults tickets. So if S is number of student tickets, then it will be 2 multiplied by the number of adults tickets. Then, as we had in the previous task, the overall number is 250, and all these are numbers of the types of tickets. So A plus S plus C equals 250. And then about the price. So we have adults, the most expensive ones, a bit cheaper for students, and the cheapest for children, which overall costs this number. For this task, actually we have the easiest third equation that we can quickly substitute somewhere to get the 2 by 2 equation system. So let's substitute here what we have. A plus 2A plus C equals 250. So 3A plus C equals 250. Let's isolate C and then substitute. So 250 minus 3A. And we will input here. So 15A plus 10S plus 8. 200 minus 3A equals 2085. So what we get? Plus 200,000 minus 24A equals 2825. And here we can also substitute S for A. So let's see what we have. 15A plus 10 multiplied by 2A minus 24A equals 825. So 15 plus 20, 35, minus 24 is 11. 825. So let's calculate what we have. 7, 55, 75. So we have adults, a number of adults tickets, 75. And here we can directly see what we have, what number of students tickets we have, because 2 students tickets is twice adults tickets. So 75 multiplied by 2, 150. And we can input our value of adults tickets into this equation. So we have 2050 minus 375. 150 minus 5, 321, 225. Oops. Two, 5. So number of children's tickets is 25. So here are our answers. Please pay attention if you use default variables x, y, z, that you correctly write the number of each type of tickets in the answer. You cannot write x equals 75, for example, because we don't understand what you use for x. We can see it, but you need to be precise with your answers. So number of adults tickets 75, number of students tickets, and children's tickets. Don't get confused with it. So it is now 7 p.m. We have 3 more challenging questions. If you need to leave, you can go. We'll mark you present. If you want to stay and look at the challenging questions, you can stay. Take a screenshot of this and we will continue. So let's look at challenge questions, which are not so challenging as you might expect. Oops. Okay. So for the first question, we need to get to find out whether all these 3 points lie on one line. Any ideas how we can do this? Please speak up if you want, or write in the chat. Any ideas in class? Okay, if we need to find if 2 points belongs to one line, how we do this? We did this previous week in workshop, and you did it in class. So just forget about the third point, what we can do with the first and the second points. What is the typical approach? Okay, for the 2 points, what we did, we used the slope-intercept formula. Then we just input the values of the 1 point and get the formula. Then we input values of the second and complete the formula. So let me show you. So firstly, we will do with p. So y for p is 6, m is unknown, and x is 9. B is unknown. So we have one equation with 2 unknown variables. Let's take the second point and the same formula, because we need to find about the line. So y is 0, m is minus, x is minus 1, so minus m plus b. So here we have the common 2x2 system of equations, and from this system we can decide, we can find out the values of m and b. And we pretend as if both these points lie on one line. We need to find this line, because as you remember, to draw the line we need 2 points only. So there is definitely one line that runs through both these points. And we need to find the equation of this line. So let's see what we have for coefficients. Let's subtract and get rid of b. What we have? 6 equals 9m plus m. So m equals 6 equals 10m, and m equals 6 over 10. Then we can put it here and get minus m, oh, minus 0.6 plus b equals 0. So b also equals 0.6. So our line looks like y equals 0.6x plus 0.6. We have the equation of one line that both of these points belong to. Then simply to check the third point, we need to input these values in this equation and check is it equal or not. So minus 5 equals 0.6 multiplied by minus 9 plus 0.6. So here minus 5 equals minus 5.4 plus 0.6. So minus 0.4 plus is not equal to 0.6. So these 3 points do not lie on one line. They do not belong to one line. Actually, to solve such questions, you can try to draw these lines, but with your hand drawing, you won't be as precise as needed to get the idea, because if the points are too close, they cannot lie on one line as well. So it is better to solve such problems with algebra, not with drawing. Okay, let's go further. Take a screenshot if you want. Let's continue. So this question is quite big and have a lot of points that are connected with each other, a lot of steps that are connected with each other. So just think how are you going to solve this question, and then we will discuss the approach. So you should use the graph on the right to solve this. So here, to solve the first one, to find the equation of f at fx, you need to use the slope. So you can choose 1 point, second point, x1, y1, x2, y2, and get the slope. Then you can use one of these points to insert into the slope-intercept form. Slope-intercept form to get b, and then you will get the value of this formula for the fx line. Parallel lines have the same slope. So for parallel lines, we will have m1 equals m2. For perpendicular lines, we have m1 and minus 1 over m. The slope for two perpendicular lines. And for the last one, you need to firstly, of course, find the equations of all the lines mentioned here, F, H, J, G. And then to find the intersection points, you need just to write the slope-intercept forms like this. So equate them and find the point where they intersect. You do the same for the second pair. And then you get point A and point B that the new line should go through. And we already used 2 points to find the exact equation of the line. So basically, it is the knowledge of slopes, how to input the coordinates of points into the equation. And the last one is the same approach as we just did with 2 points and slope-intercept formula. So please take a screenshot if you need this. You can try to solve it later on by yourself. And let's get to our last task. So what we have here? We have a person who sells food from his truck and the data. So the average customer spends $8 per order. So if the customer pays this $8, the owner of the food truck gets this $8. So it is his revenue, the price he gets for his production. So price equals $8 per order. Average cost per order amounts to roughly $4. Cost is something that the owner of this food truck pays to produce one order, like the amount of meat, for example, he uses, or the amount of electricity that is consumed while he grills something, kind of this. So for him, cost per order is $4. Every day when he works, he pays $200 as operation fee. So this is a fixed cost that does not vary depending on the number of orders, because here we have everything depended on the number of orders customers make per day, but this one does not. So we have fixed cost equals 200 per day. What we need to find? The break-even number of daily orders for the food truck. So break-even is the point, the number of orders when his profits and costs intersects. So it is the number when he neither get losses, experience losses, nor he get profit. So it is zero when overall price and overall cost for him are equal. So to illustrate this from algebra, let me write the equation. So let's x be the order number. So 8x is his profit, his revenue, not profit, revenue from the sales he makes. And it should be equal to the losses he experienced, to his costs. So 4x plus 200. The average, how it is called? Not the average, the variable cost and the fixed cost. Variable because it varies depending on the number of orders, and fixed cost because no matter how many orders he get, it will be 200. And let's take a look at the second question. If the truck owner cannot make a profit of 240 per day, he would have to change his business and be employed in office. How many orders he need to do to get the profit of 240? So profit equals revenue minus costs. So the actual money you have after paying all your fees. So our profit should be 240. Let's see, 240 equals revenue, which is 8, minus costs, which we have here. And here is our system of equations. But actually not the system, like, let's have it 1 and 2. So what we have here, for x equals 200. So x equals 15. So to break even, he needs to sell at least 50 orders. Not at least, like 50 orders to break even. And here we have for x equals 440. So x equals 110. This is the amount of orders he needs to sell in order to make $240 of profit. So you can see it's huge difference, like 2 times difference between the break-even point and at least $240 of profit. So this is this is it for today. You can take a photo. It's kind of preview question for what you will be studying next in the class. So take a look at it at home. So that's all for today. The list of exercises is here. If you want to practice by yourself, take a screenshot, so remember what we done today, and you can find them in intermediate algebra book. So thank you everyone. If you have any questions, please ask. If no, have a nice evening. Goodbye.